Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to discuss a very important pattern with respect to data engineering world, and that is incremental data ETL using Amazon SQS. Okay, so this is a very popular pattern also, especially for incremental load, and how that is performed. Let us try to understand that with this diagram. Okay, so in our traditional cloud data warehouse, let's consider that we are having multiple data providers. Okay, so here this one I can write data providers. Okay, so the data providers are sending files that can be in CSV, Parquet or Avro, any other big data file format. They are sending to our S3 data lake. Okay, so here I can write data files in S3 bar. Okay, so here data files are getting landed, and now what happens that here we are having, suppose, our ETL server that can be EMR, that can be EC2, okay, or any other compute engine provided by any cloud service, right? So what this ETL server does, they consume the data files, and after processing, after applying the transformation, business logic, etc., it ingests those data in our target database or target cloud data warehouse, right? So now in this architecture, there is a complex problem which often the data engineers need to face, and let us try to understand what is that. Okay. So for example, here we are having one S3 bucket name is ABC, and the folder name is maybe XYZ. Okay, in XYZ, first the data providers has sent two files. Okay, maybe for example m.csv and n.csv. Okay, now these two files are available in XYZ folder within ABC bucket. What the ETL server will do, when it will run, it will read all the data files, and then after processing it will load in our data warehouse. Okay, now suppose in that same XYZ folder, what happens, there two more file came, that is v.csv and then maybe z.csv. Okay, now what happens that actually in this XYZ folder location all four files are available, but our ETL job has already processed and loaded this M and N CSV file, and V and Z, these two CSV files only need to process. It no need to process M and N CSV file again in its next run. So how to make this differentiation, that what files are already processed and what not? So one approach which many architecture follows, that once the files are processed, delete those. So that means initially when M and N, these two CSV files are processed from this particular landing zone, they delete those files. Okay, but this is not always the case. Sometimes we might need to keep a historical set of our data in our landing zone. So that time we cannot simply delete it. And we need also a mechanism using which we can understand that these are only incremental files and I need to process only these two files in my next run. So how to do that? Let us try to understand that in today's video. Okay. So let me just erase all these things. So here what we can do, here we can take help of our SQS queue. Okay, so here we are having one SQS queue. So there two pattern can be followed. One is, once the data provider write the file in S3 location, what they can do, they can maybe load a metadata information that this file is ingested in this particular S3 location. Like this kind of metadata information they can put in SQS queue. Okay, so what this ETL server will do, whenever it will try to run, it will read those metadata informations from this SQS queue, and then it will have a complete list that these are the S3 files what I need to process, and then what it will do, it will read from this particular S3 location and it will process only those set of files and load in target data warehouse. Okay, so this is one approach where the data provider will write the original data file in S3 bucket and they will write the metadata information. Here I can write like this way, metadata stream. Okay, so metadata information they can write in SQS queue. Okay, and what this ETL server will do, it will iterate through all the messages present in SQS queue. That way it will have the information that these are the messages which is not processed yet, and it will process those again. Okay, so here the data provider is taking the responsibility of publishing the metadata information as well as the data. But sometimes what you can do to make this whole process simpler, instead of giving the responsibility to data provider to write the metadata information in SQS queue, what we can do, from S3 we can create a event notification. Okay, that is, as soon as some file get landed in S3, we will publish that event notification to our SQS queue, and that way in SQS queue all the informations will be available for those files which landed newly or recently. Okay, and those alone our ETL server can consume, and after consuming those messages it can process, and once the files are processed, what it will do, it will delete the messages from the SQS queue so that it will not be reprocessed again in its next run from the SQS. Okay, so this is a very frequently used architecture with respect to incremental data processing world. So now without any further delay, we will directly jump into a demo section and we will try to explore how we develop the job. Okay, so here I have built a job using Talend, but whether you are using Python, PySpark, Airflow, anything, for all those kind of ETL tools or ELT tools, you can implement the same logic. Okay, first let me show you the demo and then I will discuss what I have done in this particular job. Okay, right? So here, as I discussed, that once new file comes, that incremental files we need to load in target database or target data warehouse, right? So in any kind of incremental ETL, you can use this pattern. In this particular use case, what ETL transformation or ETL technique I have followed, that is basically I am having a source bucket. Suppose the bucket name is this one, hello testing. In this particular bucket, some files will be landed. All I need to do, I need to copy the files from this location to this destination bucket. Okay, right? And in an incremental way. Suppose now 2 files came, I will run my job. Those 2 files will be copied to our destination, but it will be available in our source also. Now next time in source, suppose another 2 file comes, I need to only copy incrementally those 2 files, not all 4 files again, right? So let's see that we will understand in a better way when we will observe the demo. So here I am having some files. So what I will do, first let me upload one CSV file here. Okay, so in my source bucket, here I am uploading a CSV file. So it is uploaded. Now what I will do, we will run our Talend job. But before running, just have a check. Here in the destination system, there is no files currently, right? All I will do, I will run my job. So here it started running. So here it is done. Now let's refresh our destination and see the same file what was available in our source system, that is available in destination now, right? Now what I will do, I will maybe upload 2 more files. Okay, so here Versicolor and Virginica, these 2 CSV files I will upload. And now what should happen when I will execute my Talend job again, then it should only incrementally copy this versicolor.csv and virginica.csv. It should not copy setosa.csv again, because here in destination system already setosa.csv is available, right? So now let's see whether incremental it is able to consume only those 2 files, that is Virginica and Versicolor, or not. So here I will run my Talend job again. So here it is running and the job is completed. So now let's go to our destination. Let's refresh and see here only Virginica and Versicolor files came in the current run. The Setosa file came at 9 AM and these 2 files now came at 9:01 AM. Okay, so this came in second run. So see the beauty. Here it only incrementally copying the data or incrementally processing the files. It is not processing the Setosa file again, which it already processed earlier, right? So now let's try to understand what I have done, how it is working, what is the mechanism of it, right? So here all I have done, in the properties section, here I have created an event notification. That is, whenever any object is created in our source system, the event will be published in the SQS queue. And for this particular POC, I have created already one SQS queue, demo test 123. So what is happening, that as soon as in our source bucket or source directory, any new file get landed, one message get published in this SQS queue. And what our Talend job is doing, if you see, that here first we are creating an SQS connection and S3 connection, because those are required. SQS connection is required to read the SQS messages, that these are the file events which came, and S3 connection is used to copy the file from one S3 location to other S3 location, right? And what I am doing here, let's start from this particular component. Here first I have entered the queue name. Okay, using this particular component we are reading the messages from this particular queue. Okay, and after that we are printing those messages in console. This is totally optional and used for only debugging purpose, right? So let me show you how it is getting printed. So here if you see, it is having a message ID. So for any message in SQS queue, a system generated unique ID is available. Receipt handler is a very vital factor which I already discussed in detail when we explored SQS with Python. This basically helps us in deleting the messages from SQS queue, right? Let's scroll little right, and here you will get the MD5 body, which is also a metadata information and vital. And here we are having our body part. Body part is basically JSON data, and it contains basically all the informations that this is the file came, when it came, what is the bucket, what is the key, all this information. So let me show you that by formatting that JSON. So I will use online JSON formatter. So here I will paste the JSON and I will click on process. So this is how our particular SQS message looks like. Okay, now from here we need to extract what is the file name and in which bucket it got landed, because these two informations are needed in the next component to read the file and copy to our destination system. Okay, right? So here you can see that first there is a component called records. Okay, and within that there is one array. Within array there is a key called S3. Within S3 there is a key called bucket. Within bucket there is a key called name. And in that name, the value part is basically our source bucket, right? So this information will help us in flattening the JSON and get the bucket name and key name respectively. So once we get the messages from SQS queue, obviously next step what we will do, we are extracting the JSON data. Okay. And let's see what we have done in this extraction phase. So here this is our extraction of JSON data code. Already I discussed in my previous video how to extract JSON data or flatten our JSON data in Talend. You can check the description link. I will provide my previous video link there. So here you can see message ID, receipt handler, MD5 of the body. These three metadata information I am passing as it is. The bucket name and file name I am basically extracting using key value pair, as I discussed that initially from parent. Within that records is the key. And records is basically one array. From there I am extracting the 0th element, because here in this particular SQS message only one message it will send at a time, because I have configured this particular property. Max number of messages to return per request I have kept 1. So I can assume that whatever JSON data will be coming in that, only one element array will be there, right? So from one element array to extract the data point, I will use array indexing, and array indexing start from 0. So here bucket name, records of 0. Within that S3, within that bucket, within that name. From there I am getting bucket name. So this is a new particular variable what we are deriving. And then the file name also needed, right? So where file name is available, within S3 there is an object, and within object there is a key, there it is available. So same particular path I have written here. $records of 0 S3 object key. Okay, right? So from there I am getting the file name. Once I get the file name, what I need to do, I am basically again printing in my console using tlogro, just to see whether everything is coming properly or not. Okay, and now once it is done, we can use AWS S3 copy component to copy the file from source S3 to destination S3. So obviously here this is basically a flow or row. From row I need to get the values, so I need to convert that to variable some way, right? So for that I am using tflow to iterate. So that way whatever rows will be coming, that will be getting converted into global variable. Okay. So here source bucket, source file, receipt handler, message ID, like that some variables I have created. Okay. Now these variables I'll be using in our S3 copy component. Source bucket I am taking as global variable. Then what is the key? Then destination bucket name here I have hard coded, and the destination file name also I am keeping same as our source file name. So using this way, the copy command is getting executed, and once it is executed, what is our next responsibility? Our next responsibility is deleting the message from the SQS queue, right? So for that, what I am doing here, obviously for deletion of message, receipt handler, whatever we are getting from SQS input, that will help us. So here we are putting our queue URL name, and here we are passing our receipt handler, which is stored in the receipt handler global variable, what we configured already in tflow to iterate here, right? So using that, we are deleting that particular message. Okay. Obviously, you have to configure the visibility timeout properly in your SQS so that once this particular pipeline is running, when this particular pipeline is processing a message, the message should not be again visible for again consumption. Okay. So take care of visibility timeout accordingly. And here, what I have done, another important property, if you see here, what I have changed, that here delete messages while streaming. This one I have unchecked. Okay, because if we check this one, what it will do, as soon as it will read the messages from SQS queue, it will delete that. Okay, but it might happen that after reading the messages in the downstream layer, somewhere it is failing, right? So we have unchecked this one. We are not deleting the messages while reading. Once the messages are copied successfully, then only we are using a separate component, that is TSQS message delete, to delete the message. Okay, this is the overall flow. Now another important point is this particular one. What I am doing here. So here if you see in SQS input, I am consuming one message at a time. But it might happen multiple files are getting landed at a single shot, or when our job is running, maybe that time 10 or 20 files are there. So 10 or 20 times I need to iterate, right? So that's why I am using a T loop component. Initially what I have done here, this particular TSQS input basically return one particular variable, global variable, which is basically number of lines. So initially I am setting number of lines what it is returning as 1. Okay. And we are continuously iterating until and unless it is becoming 0. Okay. So what will happen, initially the variable value will be 1. So here this condition will not be satisfied. So it will execute the while loop. Here in TSQS input it will come, it will consume one message from SQS queue. It will copy the data and delete the message. Then again it will come to T loop. Because earlier time it got one message, so again this loop will execute. But suppose now there is no message in SQS queue, what will happen? Basically here first it will try to run with number of lines 1, so this loop will execute for the first time. But when this TSQS input 1 will execute, that time it will not consume any message. So that way this particular variable will set to 0 because it is returning no data when there is no message in SQS queue. So after running, when again in T loop it will come, it will not run again because TSQS input 1 NB lines, this variable will be having 0 value because in my earlier run I got no message. So let me show you that currently in our SQS queue there is no message, right? Here if you see that currently here there is no message. So here if I am running, here it started. First it executed once because here initially we kept this particular value as 1. So for that this particular condition is not satisfied and it executed one time. But when it executed, it got no message. So in the next loop, the particular variable value is 0. So it will not run this particular loop again, right? And at the end, what I am doing, I am closing the S3 connection. So this is the simple way using which we can do incremental file processing. Let me show you demo another time. Maybe for example, what I will do, one file I will read as job info. So here job info.properties I am uploading. And apart from that, one more file will upload in our source system. So here maybe success file, let me upload. Okay, right, 2 files I have uploaded. Now let me go to our source bucket. So here you can see success and job info properties both are available. So what will happen, as soon as we are uploading the file in S3, in SQS queue in the message available, it should show me 2. Okay, so that will confirm that there are 2 new files which we have to process. And in this destination system, you can see job info and success file are not available. All I will do, I will run my Talend Job. Okay, and let's see what logs it is printing. That way we will have a better idea. So here you can see it iterated and it got exited. Okay, so now let me show you first what is happening in SQS. Currently message available, it is showing 2, but soon it will update, it will show 0. That is one thing. So that way no message will be reprocessed again. And the second point is, in this particular destination system, those 2 files, that is job info and success file, should be available. So see, success.txt and job info.properties, both files are available here, right? So that is basically indicating it is only doing incremental processing or incremental load, not full load or something like that. So here currently it is showing 2 messages, soon it will be deleted. So here you can see message available as 0. Sometimes it shows, but soon it get deleted. No need to worry on that. So here what is happening in logs, if you see. First, here we are printing the logs just after reading the messages from SQS queue, right? So here you can see message ID, received handler, and then here MD5, and the body part is JSON data. Now next time when we are printing the logs, that is basically after flattening the JSON. So here message ID is there, receipt handler is there as it is. But here if you see, after MD5, the bucket name and file name it has extracted using the JSON flattening or t-extract JSON component, right? Once it has done that, it is using these two to configure source bucket and source file. And already I know what is the destination bucket, and destination file name also I am keeping same as our source file name. That way the S3 copy component is copying the data to our destination system, right? So I hope you understood this incremental processing pattern, and you can use this in your project also. I'll be sharing some reference link in the description box so that you can explore more and play with it. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.